Hello everyone. Hello, hello. I am audible or visible? Hello everyone. Yes, yes, I am audible. Now we will move to the upper chapter. So we are in chapter motion and force of physics. We all know that we are in the journey of uh, physics class 10th course. So we are doing the all things from scratch to the advanced level. So if you till now not subscribe the channel, please like and subscribe, and please stay connected guys till the course is not end. And trust me, I will make you uh, make you build your confidence that much you can solve the questions just in a minute. तुम लोग चुटकी में ऐसा ऐसा ऐसे चुटकी में क्वेश्चन सोल्व करोगे। उसके लिए सबसे पहले आपको पेशेंस बनाए रखना होगा। जब तक ये कोर्स ख़त्म ना हो जाए या फिर ये चैप्टर ख़त्म ना हो जाए, तो जब तक चैप्टर ख़त्म ना हो, प्लीज़ मेक patience and stay connected with us. We will do all things from very beginning, from scratch to the advanced level. Also we will solve questions, many questions to get confidence in that topic. Also, if you have any doubt related this course or any questions regarding any topics, you can comment it out in the comment box. And also you can comment in WhatsApp community or Telegram community. My team or I will try to solve your problem as soon as possible. So guys, your doubt, your problem is our problem. So I will try to solve your problem too much, and I am also excited to solve your problem and know your problem and help you in the journey. So guys, till now we all know we have covered. Let me share the screen. So stay connected guys, and please stay connected with WhatsApp and Telegram community. Also, if you not subscribe, please subscribe it. We will get motivation to make more videos and lectures. So till now we have covered their consequence. So let me recall the previous things of day 4. So in yesterday classes we have covered consequence of gravitational force, how gravitational force uh, made existence of universe including solar system, how tides are created in the sea and ocean because the moon exerts a force on earth. Due to that, there is tide creation in sea and ocean. We see also the gravity, the force exerted by the mass of object on a smaller mass nearby, it is called force of gravity. We also derive the formula for force of gravity, and that is how much g is gmt by d square. In the previous class we have all seen what g is: gravitational constant into mass by square of distance between them, that is nothing but g equal to gravitational constant into mass of earth by radius of earth a square, that is After calculating by putting the value of mass of Earth and radius of Earth, we will get 9.8 meter per second square, because G is what is a unit of it is acceleration, na? So the unit will be meter per second square. So till now we have covered all that things. So our today class is about, let me take a pen. It is our day 5 class of motion and force. So let's check again whether that topic. Yes. So guys, if my voice is not clearly audible, please also tell all the things. I will try to put tell in I will try to tell in the mic, close to the mic, so it will be clearly audible. So till now we have seen there the force of gravity, what is force of gravity, how the force of gravity calculated, and on the consequence of gravitational force. So now we will study about what. First, let me once again tell that thing, how we will calculated their gravitational force, force of gravity, or we can say gravitational acceleration due to gravity. Sorry, it is acceleration due to gravity, and we all know weight is the force, and weight is can be written as mass time into acceleration due to gravity, and force is what? G into mass of product of mass by distance between them, that is mass cancel out, and G came to be Gm by d square. D square is nothing but radius of a square, radius of Earth squared. So we can conclude that acceleration due to gravity is inversely proportional to the radius of a square. So yes, we can also conclude that the force of acceleration due to gravity is when increases when the acceleration of radius of a square decreases, because it is inversely proportional. We can conclude now, if radius increases, then gravity decreases, because it is inversely proportional, and if radius decreases, acceleration due to gravity increases. That is, it is in which portion of Earth we will feel that the acceleration due to gravity is less. We can conclude where at the center of Earth or anywhere in the Earth, बशर्ते हम लोग को क्या रेडियस जहाँ पे ज्यादा होगा अर्थ का, पोल पे जानते हैं हम लोग का रेडियस कम होता है, तो उस वहाँ थोड़ा फोर्स बाकियों का पोर्शन से ज्यादा लगता है. दैट इज इट इज इन पोल, नॉर्थ पोल or south pole. Since the mass of falling object is not included in equation, it can confirm that fact. Acceleration due to gravity दे फ्रीली फॉल भी। हम लोग फ्री फॉल का कंडीशन देखे थे, हम लोग एक्टिविटी भी कुछ कुछ किए थे कि अगर हम लोग पेन और एक पेन बॉल एक पेन अ पीस ऑफ पेपर इस हम लोग एक पेपर को फाड़ के दो इक्वल पीस में करेंगे और एक को बॉल बना देंगे, बॉल वाले शेप में बना देंगे, एक को सिंपल रखेंगे, तो दोनों को गिराएंगे तो एक एयर रेसिस्टेंस के कारण उसका वेलोसिटी कम होता है और दूसरे वालों का वेलोसिटी ज़्यादा होता है, बिकॉज it has less air resistance. And now be in equation third, we will see that how gravity acceleration due to gravity related to radius of earth. Acceleration due to gravity depend upon the both mass and the radius of planet. We can conclude from here, if mass increases, acceleration due to gravity increases, and radius decreases, acceleration due to gravity what increases. And if and it's vice versa, if mass decreases, then what? Acceleration due to gravity decreases, and radius increases, acceleration due to gravity decreases. That's all. We can do one problem. We already defined how the acceleration due to gravity came out to be 9.8 Newton. Now moving further to the topic, variation due to gravity. What? Variation in acceleration due to gravity. Guys, are you understanding? Please let me know. If you have any doubt, please comment in the chat box, so I will know your problem and I will able to solve you. Let me check the chat box. No, till now we have no any doubts. So the average, let me tell. Okay, let's say we have a Earth. We all know that Earth is not completely round. It is in what, oval shape. Please guys, not go on my drawing. So it is Earth, and here is the center. So this distance and this distance, and let's say this distance, a big this distance is how much? 637,178 and 1370 kilometer, and this distance is how much? 63567,523 kilometer, and this distance is how much? 6371088 kilometer. So the earth is not perfectly round, we can see from here. So it is slightly flattened at the poles and bulged at the, वो थोड़ा निकला हुआ होता है इक्वेटोरियल रीजन पे. Hence, as shown in the figure, the pole and the more toward equator, since the value of acceleration due to gravity is inversely proportional to the same inversely proportional to the square of the radius of the earth, its value is more at pole than the equator. So पोल पे हमारा रेडियस कम होता है एट पोल, और जबकि हम जानते हैं कि एक्सेलेरेशन ड्यू टू ग्रेविटी इनवर्सली प्रोपोर्शनल होता है रेडियस का स्क्वायर से. सो वी कैन कंक्लूड दैट एक्सेलेरेशन ड्यू टू ग्रेविटी ज़्यादा होगा कंपेयर टू अदर रीजन्स ऑफ द अर्थ और इक्वेटोरियल रीजन. एंड इट इज and value of equatorial region is further from calculation. It is came that g is 9.78 meter per second square at equator, because इक्वेटर पर रेडियस ज़्यादा है तो ऑफ कोर्स यहाँ पे हमारा क्या कम आना चाहिए और है भी. और हमारे पोल पे जो है सॉरी 9.78 and 9, the value of g in equatorial region is 9.78 kilometer and 9.83 meter per second square. So if we calculate at equatorial region, it will come to be more than this, because radius is thought to be smaller than the radius at equatorial region. So it will be of course greater value than the equatorial region. So mostly we take a g as 9.8 kilometer in the questions, or it whether if you don't have it is given in the question, but if it is not there, you can conclude that g is how much, 9.8 meter per second square. So the average value of g on earth is considered as 9.81 meter per second square. This means that the velocity of freely falling body toward the surface of earth is increased by 9.8 meter per second square. Okay, what is g? G is nothing but acceleration. Acceleration is what? Rate of change of velocity. So we can also tell that the rate at which velocity increases velocity increases increases so we can also tell that the and if a body is under free fall, then what we can say, the acceleration of that free falling body has acceleration with acceleration as a g. So we can tell acceleration the velocity of freely falling body increases g g meter per second, that is nothing but g is what, 9.8 meter per second. That's all. So further moving to the height and acceleration to gravity topic. Now we have height and acceleration due to gravity. So guys, can you tell how acceleration due to gravity related with height? Comparison to height and a comparison of acceleration due to gravity with the increase in distance from the center of Earth. If we increase the distance, or we can say height uh, from the Earth is 2r, or we can conclude that the distance from the center of Earth is 2r, then what will be the acceleration due to gravity? Can anyone tell in my tell me in chat box? Guys, let's say we have Earth, then it is how much r, and let's say it is 2r, up to this point it is 3r, and up to this point it is 4r. So can you tell what will be the acceleration due to gravity with respect to 2r and 3r and 4r? If anyone can help me in this, I will shout out her name, his or her name. Okay, no one is there, so I will do it my own. So let me take one table. We have multiple columns and rows. So here distance is when the d is d, when the d is 2r, when the d is 3r, when the d is 4r, when the d is 5r, and when the d is 6. So we all know the formula of acceleration due to gravity is gm by square of distance between them. So we can calculate g1 as g into mass of Earth by radius of a square, which, and here g is g of m1 into 2r square will be how 2 of r square become how much, 1 by 4 4r square, and here g3 will become how much, G into mass of Earth, mass of Earth, mass of Earth by 3r whole square will become how much? 9r square. And G4 will become how much? G into mass of Earth by 16r square. And G5 will become how much? G into mass of Earth by 25r square. And G6 will become how much? G into mass of Earth by 36r square. And we will put all the value, we will get all the acceleration due to gravity. So if we put here the acceleration due to gravity came to us, all we know, 9.8 meter per second square. Earlier we have solved that. If we do, we have to not do every time. We all know gm by r square is, it is 1 by 4 into gm by r square, and it is nothing but 1 by 4 into 9.8 meter per second square, because gm by r square is 9.8 meters per second square. So here we can also write 1 by 9 into gm by r square, and here we can also write 1 by 16 into gm by r square, and here we can also write 1 by 25 into gm by r square, and here it will came as 1 by 36 into gm by r square. So further we can put also value 1 by 4 into 9.8 and 1 by 9 into 9.8, 1 by 16 into 9.8, 1 by 25 into 9.8, and here it will come as 1 by 36 into 9.8. We can calculate the value as this will become how much? 2 and 2.6, 2.4, it will come to as 2.45 meter per second square, and it will become how much? 1 point, how much? 1.8 approx. Further you can calculate similarly, so I'm leaving it to you as a homework. You can calculate it. So we can see if the distance from the earth increases, or we can say if the height increases from the surface of earth to 2r or 3r, then the acceleration of gravity, we can see here it is decreases. Be all seen here. So accordingly we have to calculate it. As the height above the surface of earth increases, the value of acceleration due to gravity decreases. We can see here if distance is r, the value came out to 9.8 meter per second square. If the value is 2r, then the value came out to be 2.45 meter per second square, and if the value is 4r, then it will become 1.8 meter per second square. Further it will decrease more. So we can conclude that if the height above the surface of earth increases, the value of acceleration due to gravity decreases. We can conclude now the value of acceleration due to gravity decreases with increase in height from the surface of Earth. That's all. That is the variation of acceleration due to gravity with respect to height. Further, we will do a problem to observe better. We can also conclude that G is, if let's say this is Earth and we go up to h height from the Earth, then we can conclude that this is R. Let's say at distance R, height h, satellite is revolving. We can conclude that acceleration due to gravity at this point also. That is how much? Gm plus R plus h square. That is telling in book. So we can do it by your own. Now we will do one question for better visualization. Till now we have done all that thing. Now we will do a question. So it is given that the mass of Earth is 5.97 into 10 to the power 24 kg. Also, the radius is also given. Radius of Earth is given as 6371 kilometer. That is nothing but 6.3 into 10 to the power 3. No, we have to write all. 6.371 into 10 to the power 6 kilometer. First, we also have to deliberately look into the unit. If we done any mistake, then our answer not get correctly. So we have to find the it is given the mass of Earth and radius of Earth, and it is telling that we have to calculate the acceleration due to gravity of International Space Station situated at the altitude of 400 kilometer above the surface of Earth. Let's say we have Earth, and it is given that radius is 6371 kilometer and mass of Earth is 5.97 into 10 to the power 24 kg. Also, it is telling that the International Space Station, let's say here it is, and it is situated at the 400 kilometer above the surface of Earth. We can conclude here this distance height h is 400 kilometer. It is given. We can write it as 4 into 10 to the power 6 meter. So we are we have given also altitude, or we can say height above the surface of earth. Height above the earth surface where a space international space a space station situated is equal to 400 kilometer. We can write it as 4 into 10 to the power 6 meter. So we have to calculate the acceleration due to gravity at that height. Acceleration due to gravity at that height. We have to calculate it. Guys, please pause the video and you can try. You can do it. If you not, let me solve. So we have acceleration due to gravity as gm by r square, or we can also write it as gm by distance between them. We all know now that acceleration due to gravity is gravitational constant into the mass of earth by distance between them, or we can say radius of earth, or distance if it is situated at the some distance height, then it can be written as gm by r plus h square, where r is the radius of earth and h is the height above which height above the surface of earth which where it is situated or located. So we can put the value directly to get answer. So we can put the value as g as 6.67 into 10 to the power minus 11, and mass of earth has 5.97 into 10 to the power 24 kg by r as a how much 6 point we can take simply to whole value as 6371 meter plus 400 kilometer 400 kilometer, that is 4 how much 40 lakh meter. So we can calculate it as 6.67 into 5.97, 10 to the power 24 minus 11, and it will come as how much. So we also have to square it, forget to put. So it will came as how much 6771 and it is 1230 whole square. From here we can multiply it to get how much? 3.3, it will come as 39.82 into 10 to the power 13 by 4 point. We can take it as how much? 4.60 into 10 to the power 13. It will cancel out. Further it will remove, so the final value is 3982 divided by 460, which is 8.66 meter per second square. That's all. We can conclude that acceleration due to gravity at height h from the surface of Earth is 8.66 meter per second square. Guys, we are doing all this very slowly, and please trust me guys, I will cover whole topic, whole concept, and sufficient question to build your confidence enough to that you can do any questions in a minute, or just in a minute. तुम चुटकी में ऐसे क्वेश्चन ऐसे ऐसे करके सॉल्व करोगे। बस हम तुमसे बस यही चाहते हैं कि जब तक कोर्स खत्म ना हो बस यहाँ पे बने रहो, and I will make that much confidence you can do board questions in a minutes, and you can solve enough, you will build your confidence that far that you can that you can do the questions in a minute, and you have much great confidence to do advanced questions. You will develop all that confidence. Just you have to make patience and be with me. So further we will move to the other topic. There is also another questions there. It is telling that the distance at the top of field from the center of the earth is greater than the distance of bottom of the center of earth. The value of g is less than the top of the hill that at its bottom, but such a difference is very small. For example, the height at Mount Everest is 8,848.86 meter. The distance at the center of Earth to the peak of Mount Everest is radius plus height above the surface of Earth where it is situated. That is 6,371 kilometer plus 8,848.86 meter. And the same concept is applied there. That is G is gm by r plus h square, where g is gravitational constant, m is the mass of Earth, and r is the radius of Earth, where it is taken as how much? 6371 meter plus height of Mount Everest, that is 8,848.86 meter to the whole power 2. and we will calculate it as how much, 9.78 meter per second square. Same concept is applied there, so we will not do that. So now we have the question, that is the value of acceleration due to gravity g. Let me write this question. So guys, we are following Circulum book, as I earlier told also. If you have a Circulum book, so please take it, and you can follow with me. Also, for the doubts or other problem, you can uh, put a message in the group or chat box, so I can help you for any concept related issue or any numerical related issue. You can put a message, that's all. For the concept, we are following Circulum book. You can follow with me. If you have Circulum book, you can take and follow with me. So we have a question, that is acceleration due to gravity g is given that 9.8 meter per second square. We have given that the acceleration due to the gravity of earth is 9.8 meter per second square, and if the mass of the moon is, so mass of moon is also given as 7.35 into 10 to the power 22 kg, and the radius of earth, so radius of earth is also given as 1.74 into 10 to the power 6 meter. What is the acceleration due to gravity of moon? So we have to find this given there. Find the acceleration due to the gravity of moon compared to the acceleration due to the gravity of earth and that of moon. Also we have to compare the gravity of moon and gravity of earth. We have to compare between them. So first we will, for comparing, we will take directly ratio gravity of earth, acceleration due to gravity of earth and acceleration due to the gravity of moon. So first let me calculate the acceleration due to the gravity of moon. So acceleration due to the gravity of moon will become how much? G into mass of moon by distance between them. So compared to the radius of moon, it is negligible as compared to the radius of earth. So we can take radius of earth whole square as a distance between them. So we can conclude that, first let me calculate, g is 6.67 into 10 to the power minus 11 into mass of moon we have given as 7.35 into 10 to the power 22 kg, and radius of earth as 1.74 into 10 to the power 22, sorry it is 6, and we can square it to get the स्क्वायर डिस्टेंस बिटवीन देम. सो बेसिकली हम लोग यहाँ पे क्या किए, हमारा ग्रेविटी ऑफ एक्सेलेरेशन ड्यू टू द ग्रेविटी ऑफ अर्थ हमारा दिया गया है क्या, 9.8 मीटर पर सेकेंड स्क्वायर, एंड द मास ऑफ मून दिया गया है 7.35 इंटू द पावर 22 kg, और रेडियस ऑफ अर्थ भी हमारा दिया गया है. तो हम लोगों को फाइंड करना कि ग्रेविटी ऑफ मून क्या है और कंपेयर टू द moon, how it is, whether it is greater or smaller. So और कंपेयर करने के लिए हम लोग रेशियो निकाल देंगे. सो हम लोग यहाँ ऐसा करेंगे कि सबसे पहले ग्रेविटी ऑफ मून निकाल लेंगे. सो ये हमारा आएगा कितना, 6.67 इंटू 7.35, इट इज 35 ना. सो 22 minus 11, and it will become how much, 1.74 into 1.74 into 10 to the power 12. So it will came as 6.67 into 6.67 by 1.74 into 1.74, and it will become 11 from here, and it will, if we go to here, it will become 10 to the power minus 1, and it from decimal will be cancelled out. Further it will came out to be 1.62 meter per second square. So we can see here the acceleration due to the gravity of moon came out to be 1.62 meter per second square, and compared to the earth, how we can compare, we can compare by taking the ratio or proportionality, that is gravitational of earth to the gravitational gravity due to the moon. Sorry, it is ratio of acceleration due to the gravity of earth by acceleration due to the gravity of moon, that is 9.8 meter per second square by 1.62 मीटर पर सेकेंड स्क्वायर. हमारा जो ग्रेविटी ऑफ मून आया वो कितना आया, कैलकुलेट करके जो फाइनल रिजल्ट आया वो आया हमारा 1.62 मीटर पर सेकेंड स्क्वायर. और जो हम लोग को पहले दिया गया है एक्सेलेरेशन ड्यू टू द ग्रेविटी ऑफ अर्थ, जो कि है 9.8 मीटर पर सेकेंड स्क्वायर. सो हम लोग रेशियो निकालेंगे कंपेयर करने के लिए. सो हमारा जो है 9.8 बाई 1.62 लेंगे, तो यहाँ पे एक ऐसे कर सकते हैं. तो ये जो हमारा आएगा अब अराउंड 6.05 के आसपास आएगा. तो हम लोग ऐसा बोल सकते हैं ग्रेविटी एक्सेलेरेशन ड्यू टू द ग्रेविटी ऑफ अर्थ है वो 6 टाइम अप्रॉक्स 6.05 टाइम्स ग्रेविटी ऑफ मून के बराबर है. So if we can conclude that acceleration due to gravity is 6 times less than the is 6 times moon. From here we can conclude. So moving to the further topic, we have mass and weight. We already know about what is mass and what is weight. Mass and weight. Mass is m and weight is mg. So basically it is a force, and this is the fundamental quantity, that is mass m. So weight of an object is related to the acceleration due to gravity. Of course we have seen that the weight is mg, जो इसमें g का टर्म included है, so that we can conclude that the weight of object is related to the acceleration due to the gravity. If और हम लोग बोल सकते हैं if g decreases then the weight decreases. If the g increases, weight increases, because it is the product of mass into gravity. We can clearly see there weight increases with g, and decreases with g decrease. When g decreases, weight decreases. So the total quantity of matter present in an object is its mass. कोई भी ऑब्जेक्ट हम लोग लेते हैं तो उसके मास क्वांटिटी, जो उसका टोटल क्वांटिटी ऑफ मैटर परसेंट होता है, उसी को हम लोग मास बोलते हैं. This mass, this mass mass. So in simple word, we will define mass as a the total quantity matter percent in object that is mass. And this is the scalar quantity. What is a scalar quantity? First let me know. If you know, please comment in the chat box. That is nothing but the quantity which has there are basically two quantities, that is a scalar quantity and vector quantity. We will not study vector quantity in class 10th. For your knowledge, let me tell that there is two quantity. One is a scalar quantity and the other is vector quantity. The scalar quantities, that no, it I suppose that the vector quantities also that will be studied in class 10th. So anyway, we are in what is a scalar quantity. A scalar quantity is that quantity which has only magnitude. The quantity that has only magnitude. And the quantity which has both magnitude and direction. So we have studied that the example is mass, and the example of vector quantity is current. Many things are there, or torque, or your we can or tell that velocity not the speed is higher. Yes, velocity also, it has direction and magnitude. So when it is taken negative, then it is, we can conclude that it has magnitude and direction. So for your knowledge, there is also another quantity, tensor is there. For your knowledge, just I am telling that, but we will study more deeply in higher studies. So just for now, we will study that there is a scalar mass is came to in the category of a scalar quantity. So if we the SI unit of mass is what? Kg. So no matter whenever a 1 kg of mass iron is kept on Earth, International Space Station, or the Moon or Mars, etc., the quantity of iron in it always a 1 kg. ऐसा नहीं है कि अगर हम कोई भी 1 kg ऑफ आयरन को यहाँ उठाएंगे तो और 1 kg आयरन को स्पेस में और एनी इंटरनेशनल स्पेस स्टेशन पे मेजर करेंगे तो वो 1 kg का 2 kg हो जाए, 2 kg को 5 kg होगा. मास इज ऑलवेज कांस्टेंट. यहाँ पे भी 1 kg होगा, एक इंटरनेशनल स्पेस स्टेशन पे भी 1 kg होगा और एनीवेयर इन द स्पेस भी 1 kg होगा. सो the quantity of iron in it always 1 kg. Therefore, the value of mass of an object does not changes according to the places. We all seen there. If we measure if you can do that, please do. If you measure a mass of iron in the place you are now and the place if you measure at some time at after some time another place, then it will be same. You can clearly observe, but you can see with the weight. We have already seen that the acceleration, it is dependent on the acceleration due to the gravity. So we can acceleration due to gravity is less at the pole, and the acceleration due to the gravity is so, uh, what let me tell once again. Acceleration due to the gravity at pole is less, and the acceleration due to the gravity at equator is high. Oh, let me, what is acceleration due to the gravity? Let me explain more clearly. Gm by r square. So at the pole r square is decreases, so g is increases. So at the pole the acceleration due to the gravity is um, so the weight will be more because g increases, then the mg also increases, so the weight will be more at the acceleration at the pole, but at the equator it will be less. So it is not like that mass is always same at the other place. It does not change at with respect to place. Also, Earth gravity pulls object on its surface at its center. So till now, we will study up to that mass and weight variation with respect to place. So today what we have studied that we have seen the questions how gravity acceleration due to the gravity increases with changes with mass and radius, that it increases with increases in mass and it decreases with respect to the distance between them. So if it decreases and distance decreases, then the acceleration to gravity increases. So, and if it is increases, then the acceleration due to the gravity decreases. Also, we have seen the variation in acceleration due to the gravity at the pole, at the center or equator. How acceleration due to the gravity changes with respect to the height above the surface of Earth, that is gm, just adding the distance to the radius of Earth, that is gm plus r plus h square. And we have seen, we have done problem also how mass and weight changes with respect to places, we have seen. So that's all from my side today. So later on we will study about the variation in weight due to the changes of acceleration due to the gravity, and many more things. We will do many more questions and free fall and so on. So if you have any doubt or any issue regarding the concept or numerical problem, please comment it out, guys, and make sure you have to subscribe to stay connected. If my video will be came, then it will be directly give you a notification. Please make sure you have subscribed the and put a bell icon, hit the subscribe bell icon, and any issue you can also chat, put a message in WhatsApp chat or Telegram community. So keep learning and exploring, guys. That's all. Thank you.